Concept 2, graphing functions. So when you're graphing the whole function, you are going to be graphing points, just like when you're graphing partial solutions, but you're also going to be connecting those points to form a line or a curve. Okay, and that curve is going to plot out points that will be on the graph, but maybe you didn't even figure out those specific points. Okay, so your first step is to choose several points for your x value. All right, I always choose at least one negative, 0, and at least one positive. But I will sometimes change the points I choose. I won't always just choose -1, 0, +1, and then 2. For instance, when I have a fraction or I have my x value being divided by something, I will usually choose multiples of the denominator. Okay, so here I have 2/3 x minus 3. I'm only going to choose multiples of 3. Okay, so I'll have -3, -3, 0, 3, and 6. Okay. Sorry, my mouse is not cooperating. And the reason I do that is I'll always end up with whole values, right? I won't have any fractions for y, at least as long as I'm not adding or subtracting by a fraction. So your rule is going to be this part of your function. So I have -3 times 2/3. -3 times 2/3 is going to be -2. Minus 3 is going to be -5. 0 times 2/3 minus 3 is -3. 3 times 2/3 minus 3, -1. And 6 times 2/3 minus 3 is going to be 1. Okay. And now that we've got our values, we can plot those points. At -3, we have -5. At 0, we have -3. At 3, we have -1. And at 6, we have 1. Okay, so we have our line or our points plotted, and we can see that we have what looks like a pretty clear pattern where we are going to be able to connect those dots and be confident about the results, not just on our line, but on, or not just on this section of our line, but on any point in our line. So let's see if we can get these to line up. Somewhere about there. Might be off by a little bit, but that looks about right. Okay. All right. The reason you want to come up with more than just a couple of points for your line is because your line might not be, or your graph might not be a straight line. It might not be linear. It might have a bend in it. It might have a curve to it. There are a lot of different types of functions, and you want to make sure that your function, your graph of that function is accurate. So if I took this function, the absolute value of x minus 2, if I just used positive values of x, I would come up with a straight line. So if I had 1 minus 2 would be down -1. Okay, 2 minus 2 would be 0. 3 minus 2 would be 1. And this would be the graph that I might draw for this one. Oops, except not so curved at the end. Right, and if I put arrows on that and I continued that going the whole way, that would be a very inaccurate graph. Okay? I would need to realize that, okay, now put in some negative values. Well, negative 2x is going to turn, or negative 2 for x inside the absolute value is going to turn into positive 2, and that's going to have me back up at 0. Oh, so now I'm definitely going to have to put in some other negative values to make sure that I see where my graph is going to go, and I see that my graph is actually going to be something like that. Okay.